Welcome back to another video by Adeptis Academy. Today we're diving into the fascinating world of engineering. We'll be exploring two important concepts, compound systems and friction. Get ready to have your minds blown by the amazing mechanics that make our world work. Have you ever wondered how a simple bicycle can take you so far, or how a crane can lift incredibly heavy objects? These incredible feats of engineering are made possible by understanding and utilizing the power of compound systems and friction. Get ready to put on your thinking caps as we unravel the mysteries behind these engineering marvels. Imagine building a tower with blocks. Each block is simple on its own, but when you start stacking them, something interesting happens. You start with one, then add another and another. With every block, your tower grows taller and more impressive, becoming much more than just a pile of pieces. Each block by itself is simple, but together they create something bigger and stronger. The blocks support each other, and the tower stands tall because of how they work together. That's the basic idea behind a compound system. It's when simple parts or machines are combined to make something that can do more than any single part could do alone. In engineering, a compound system combines several simple machines to do work. These systems are everywhere, from the tools we use at home to the machines that build our cities. These simple machines work together, each playing a crucial role in the overall function of the system. When they interact, they can move heavier loads, change the direction of force, or make tasks easier and faster. A bicycle, for example, uses wheels and axles, levers, the pedals and handlebars, and pulleys like the chain and gears to create a fun and efficient way to get around. All these parts work together so you can ride smoothly and quickly, turning your energy into motion. Think about a pair of scissors. It seems simple, right? But if you look closer, you'll see it's actually made up of more than one simple machine, but it's actually a compound system. The two blades act as levers, and the point where they join is a pivot, which is another simple machine. It uses two levers joined together, and that joint acts like a wedge, making it easier to cut through things. By combining these simple machines, scissors can cut paper, fabric, or even tough materials with just a squeeze of your hand. That's the power of a compound system, simple parts working together to do something amazing. Compound systems are essential in engineering because they allow us to achieve much more than we could with simple machines alone. They can amplify force, making it possible to lift heavy objects or move things quickly. Consider a car jack. It's a compound system that uses a lever and a screw to lift a heavy car. On their own, neither a lever nor a screw could easily lift the car. But working together in a compound system, they give us the mechanical advantage needed to get the job done. From cranes lifting massive shipping containers to robotic arms performing delicate surgery, compound systems are the backbone of countless technologies we rely on every day. Now let's talk about friction. Friction is a force that opposes motion when two surfaces rub against each other. Imagine trying to slide a heavy box across a rough floor. The rougher the floor, the harder it is to push the box. That's friction at work. Friction is everywhere, and it plays a crucial role in our daily lives. Without friction, we wouldn't be able to walk, hold objects, or even stop our cars. It's a fundamental force that influences how things move and interact in the world around us. But friction isn't always about pushing and sliding. It also exists in other forms, influencing everything from the movement of air and water to the way objects roll. So let's dive deeper into the different types of friction. Friction isn't a one-size-fits-all force. In fact, it's a complex phenomenon that shows up in many different ways, depending on the situation and the materials involved. Whether you're walking, driving, or even just picking up a pencil, friction is quietly at work, shaping how things move, or don't move, around us. It exists in various forms, each with unique properties and effects. Engineers and scientists spend a lot of time studying these different types of friction to design better machines, safer vehicles, and even more comfortable shoes. Understanding friction helps us solve everyday problems and invent new technologies. Let's explore some of the most common types. First, there's static friction. This is the force that keeps things in place, even when you try to move them. It's the reason your coffee mug doesn't slide off your desk every time you bump into it. This is the friction that prevents an object from moving when a force is applied. Static friction is actually stronger than you might think. It can hold objects in place until you push hard enough to break its grip. Think about a book resting on a table. Even if you nudge it gently, it stays put, thanks to static friction. You need to apply a certain amount of force to overcome static friction and start the book moving. This threshold is called the maximum static friction, and once you exceed it, the object finally starts to slide. Next, we have kinetic friction. This is the friction you feel once the object is already moving. It's usually a bit weaker than static friction, but it still resists motion. Once an object is in motion, kinetic friction comes into play. It acts in the opposite direction of movement, making it harder to keep things sliding smoothly. This is the friction that acts against a moving object, making it harder to keep it moving at a constant speed. That's why you have to keep pushing to keep something sliding, even after it starts moving. Imagine pushing that same book across the table. You need to keep applying force to overcome kinetic friction. But what if, instead of sliding, you roll the object? That brings us to rolling friction. This type of friction occurs when a round object, like a ball or wheel, rolls over a surface. Rolling friction is usually much less than sliding friction, which is why wheels and ball bearings are so useful in machines and vehicles. It's generally much weaker than static or kinetic friction, which is why it's easier to move objects by rolling them. That's why we use wheels on cars, suitcases, and even office chairs, to make movement smoother and require less effort. And finally, we have fluid friction. This type of friction happens when an object moves through a fluid, which could be a liquid like water or a gas like air. This friction happens when an object moves through a fluid like air or water. Fluid friction is what slows down a swimmer in a pool or a cyclist riding into the wind. It's why you feel resistance when swimming or why a parachute slows down a skydiver's fall. In fact, fluid friction is a key factor in designing everything from airplanes to swimsuits, helping us move more efficiently through air and water. So, as you can see, friction isn't just one thing. It's a whole family of forces, each playing a unique role in our everyday lives. Friction is everywhere. It's one of those invisible forces that shapes almost every moment of our daily lives, even though we rarely stop to think about it. From the moment you wake up to the time you go to sleep, you experience friction in countless ways. It's there when you pull your blanket off, open a door, or even brush your teeth. It's the reason you can walk without slipping, whether you're on a dry sidewalk or a slightly wet path after rain. Friction is why your shoelaces stay tied, holding the knot together as you move throughout your day. It's also the reason cars can brake and come to a stop, keeping us safe on the roads by allowing tires to grip the pavement. Think about writing with a pen. Without friction, the pen would simply slide across the paper, leaving no mark behind. Friction between the pen tip and the paper allows the ink to transfer, making it possible to record your thoughts, notes, or even doodles. This simple act of writing is just one of the many ways friction helps us express ourselves every day. When you strike a match, friction is at work again, creating enough heat to start a fire. That heat, generated by rubbing the match against the box, ignites the chemicals on the match head. Friction is also essential in machines and technology, making sure parts move together smoothly and efficiently. It helps gears mesh together in engines, preventing them from slipping and ensuring power is transferred where it's needed. Friction allows conveyor belts to transport objects, keeping packages moving steadily in factories and warehouses. It also enables brakes to function in vehicles, helping us slow down and stop safely. Without friction, our world would be a very different place. Imagine trying to walk on ice all the time, or objects sliding away with the slightest touch. Life would be much more slippery, unpredictable, and even dangerous. Friction may be invisible, but it's truly essential to everything we do. Friction can be both helpful and challenging depending on the situation. We've already discussed its many benefits like enabling movement, providing grip, and facilitating various tasks. But friction can also create problems. For example, friction generates heat, which can be problematic in machines with moving parts. Excessive heat caused by friction can cause wear and tear, reducing the efficiency and lifespan of machines. That's why engineers use lubricants like oil and grease to reduce friction between moving parts. Friction can also make it harder to move objects efficiently, requiring more energy and force. Think about pushing a heavy piece of furniture across a carpeted floor. The friction between the furniture and the carpet makes it a challenging task. Understanding compound systems and friction is crucial for budding engineers and curious minds alike. These concepts help us comprehend the mechanics of the world around us, from simple everyday objects to complex machinery. By learning about compound systems, we can appreciate the ingenuity behind the tools and technologies we rely on daily. Understanding friction allows us to optimize the performance of machines, improve safety, and design innovative solutions to real-world problems. Whether you're fascinated by how things work or dream of designing the next groundbreaking invention, knowledge of compound systems and friction is a fantastic starting point. Thank you for joining me on this exciting adventure into the world of compound systems and friction. Remember, engineering is all around us, so keep asking questions, stay curious, and never stop exploring the wonders of how things work. Until next time, keep those engineering minds active, and remember, the only limit to what you can achieve is your imagination.